In this video tutorial, I will be doing an introduction to differentiation, so calculus for AS Pure Mathematics, GCSE Further Maths for the AQA Level 2 spec, and also A2 Level Pure Maths as well. So differentiation, okay, looking at E1. Okay, so you have entry 1. So f of x is equal to x cubed plus 5 halves x squared minus 4x plus 3. Part A, find f dash of x. So find the first derivative of x. So when we differentiate, guys, if it's in the form ax to the power of n, okay, we do a dy by dx of the function, okay, of, okay, this function here. This is equal to, so the power comes down as a multiplier. So we have an or na, we have x, and then we knock off from the power. So we reduce the power by 1. Okay, so the power goes down by 1. So here, x cubed, so think of it as a 1 here. I do 1 times 3 is going to be 3. Then I've got the x. Then I knock off from the power, so the power goes down by 1, reduces by 1, becomes a 2. This next one, plus I have 5 halves times 2, so I have 5 halves being multiplied by 2. That will give me 10 halves, or these 2's just cancel using our rules of fractions. So think of it as 2 over 1. 5 times 1 is going to be 5 over 1 times 1 is going to be 1. So we're going to have equal to 5 there. Okay, so plus 5x, and then we knock off the power, so x to the power of 1, or any number to the power of 1 is just itself, so I don't need that 1 there. Minus 4x differentiates to minus 4. So again, think of it as minus 4x to the power of 1. So I do 1 times minus 4 is minus 4. Then I knock off the power. That becomes x to the 0. But we should know from GCSE maths that any term or number to the power of 0, excluding 0 to the power of 0 or 0 to the 0, is equal to 1. So this just obviously goes to minus 4. And then the plus 3 differentiates just to 0, okay, because constants, differentiate to go to 0. Okay, so if you want, you can obviously put a plus 0 there, but it doesn't really matter or make much of a difference. Okay, so that's the first part done. Part B, find the exact coordinates of the points of f of x where the gradient is equal to 4. So I'm going to set this f dash of x equal to 4. So I'm going to have 3x squared plus 5x minus 4 is going to equal to 4, because this is, f dash of x is called my gradient function. So when the gradient is equal to 4, then this whole thing is equal to 4. So I'm going to subtract 4 on both sides. Okay, so we are going to get 3x squared plus 5x minus 8 is going to equal to 0. I'm now going to factorize this either by inspection or the AC method. And because we are looking at, obviously N of maths here, so we obviously can use a calculator now, so we'll obviously solve that quadratic. Okay, so I'm going to try and do, by inspection, if I can, make it equal to 0. So two numbers that add to make positive 5 and times to make minus 8. Obviously one of them here is being times by 3x. So if I put plus 1 there, minus 8, that would be minus 5. So it needs to be plus 8 there, and then minus 1 there, because then you'll get 3x squared minus 3x plus 8x makes the plus 5x, and then plus 8 times minus 1 makes minus 8 or negative 8. So the solutions to this quadratic, when I solve it, we get x is equal to minus 8/3, or x is equal to 1, but we're not actually finished. We've now got to work out the y value or the f of x value. So we've now got to sub in minus 8/3 and 1 respectively into this. So let's actually go for 1 first. Okay, so if I sub in 1, I'm going to have 1 cubed, which is equal to 1. So 1 plus 5 halves, subtract 4 plus 3. Well, let's obviously simplify this bit here, okay? So we're going to have minus 4 plus 3, that'd be minus 1. And then 1 minus 1 goes to 0, so that will just go to 5 halves. And then this one, we're going to have minus 8/3 all cubed. Okay, so I'm going to try and do this here on my calculator. Okay, so I'm going to have minus 8/3 all cubed plus 5 halves brackets 8/3 squared, okay, or minus 8/3 squared. Obviously, if you square negative, obviously it becomes positive, so it doesn't really matter here if you put in positive. And then minus 4 lots of minus 5 halves. Sorry, why have I put minus 5 halves? Yeah, sorry, minus 8/3 and then plus 3. You'll get 337/27. Okay, so your two coordinates are going to be minus 8/3 and 337, or 337/27, and okay, let's just delete this part for a second. Okay, and 1 and 5 halves. Okay, let me just double check here when I put 1 in to make sure I've got the right answer. So 1 plus 5 halves minus 4 plus 3 is indeed, yeah, 5 halves. Yeah, I was double checking that. Okay, so yeah, so these two are the coordinates of f of x when the gradient is equal to 4. So this is our gradient function f dash of x of first derivative dy by dx, or you might see it written as f dash of x, or you might see it written as f dash. Okay, if you have f double dash, that means the second derivative. Okay, or you might hear teachers obviously pronounce it as f primed or f double primed of x, or dy by dx, or d2y by dx squared, or d by dx of the function, yeah, f of x. Okay, or d2 by dx squared of f of x. Okay, but that, guys, yeah, is differentiation summarized in the form y is equal to ax to the n. Okay, so just a quick summary and a quick recap. The power comes down as a multiplier and the power goes down by 1. So dy by dx, okay, or f dash of x or f primed of x becomes na or an to the x to the n minus 1. Okay, and I'll put that as y dash here to obviously save time. But yeah, dy by dx or y dash or f primed. But yeah, so this is, yeah, a notation for finding the first derivative of our function in terms of x to the power of n, or ax to the n. Thank you.